Now we have to see few terms related to that, your simple harmonic motion. So this is nothing but the displacement of the particle which has been given, that is a y is equals to a sine omega t. So that also we will see. So first, that is a time period. Obviously the time taken by the body to complete one oscillation is known as the time period. It is denoted by that your capital T. Again its displacement, you can write it down that y is equals to a sine omega t if the particle is starting from the mean position, or you can also write it down that function, that is a sine omega t plus alpha. So if alpha is equals to 0, that means the particle is supposed to start from the mean position. Yeah, and let's say this is nothing but your alpha. Yeah, so initially either you can say that if alpha is equals to 0, then definitely you can say that, so this is your y is equals to a sine omega t. Now at the same time, if I just consider if alpha is equals to pi by 2, then in that case you can say that your sine of omega t plus pi by 2, and which one I can write it down, that is a cos omega t. So y is equals to a cos omega t when there is a phase shift of 90 degree. Yeah, so in that case the displacement of the particle is given as y is equals to a cos omega t. So this is nothing but the mean position, this is the extreme position A and B. And again one more thing I can say that for this particular case, so when it is at extreme position, there is a phase shift of pi by 2. There is a phase shift of pi by 2 when it is at extreme position as compared to mean position. So there is a phase shift of pi by 2, and in that case your displacement becomes y is equals to a cos omega t over there. So this is the time. So we have seen that, so time taken by body to complete one your revolution, or that one complete your motion. So the number of oscillations completed in 1 second by that body, that we are going to call it as a frequency. Again we know that, so frequency is equals to 1 upon t. So this one also we can write it down, omega is equals to 2 pi by t, or t is equals to 2 pi by omega. So we can just put one more value for that, your omega. So that also it is given that omega is equals to square root of k upon m. So this one also I can write it down over here. So omega is equals to, again this is square root of k by m. So this is 2 pi square root of m upon k. So that is nothing but your time period, so which you can write it down for the given your simple harmonic motion. So this frequency obviously, which is simple 1 upon t, and similarly you can write it down, that is 1 upon 2 pi. Yeah, and this one, so this is where we have written that m upon k. So for this case you can write it down, it is a k upon m for this particular case. So now what is the angular frequency? So that is obviously this omega, which is nothing but the rate of change of your angular displacement, and that is given as a 2 pi mu. That mu is nothing but frequency. Yeah, and its at SI unit is obviously for that your, for frequency we can say that it's hertz or per second over here. So this is again the displacement, the basic definitions. So we will see that. So obviously the displacement is nothing but, so which changes uniformly with time in periodic motion is called as a displacement. Yeah, so that is a maximum displacement. So we can say that, you can say that the maximum displacement, so in which case you will get the maximum amplitude. So obviously the maximum displacement, so the particle is at now at your mean position. Now it has been just moved towards the extreme position, so the displacement is maximum. Let's say it is denoted by either y or it is denoted by either x for that particular case. Yeah, so this is what we can say about the displacement. Again, the amplitude, the maximum displacement in any direction from the mean position, that's just I told you. So that is nothing but your amplitude. Let's say the maximum displacement is a. So while meanwhile let's say this a dash is denoted by your y, or x. Yeah, so that is nothing but one is displacement, another is the amplitude, so which is maximum under certain condition. Then again your phi, so to define that phi we have just seen one thing, so where I'm just saying that about your simple harmonic motion, and in that simple harmonic motion I told you that so the particle first of all it is just performing that to and fro motion, and then again at the same time, yeah, so it is having some initial phase shift phi. So this is having some initial phase shift phi, and then this is omega t. Yeah, so this is how I can just elaborate it. Yeah, so this is having some value of phi and this is theta. Okay, so then definitely so we can say that so y is equals to sine of your omega t plus phi. Yeah, so if I just define that relation also, if I define that relation also, so according to this one, so if I consider this angle, so which is omega t plus phi, yeah, and this is taking the projection, this is your x and this is nothing but your a, so cos of omega t plus phi is equals to x upon a. So you can write it down, x is equals to a cos of omega t plus phi when the particle is starting from the extreme position. So for that particular case we can write it down this expression where I can say that x is equals to a cos of omega t plus phi, that phi is also called as a initial phase or that is also called as a epoch. Yeah, so that is nothing but what we will call it as a phase.